Assalamualaikum warahmatullahi ta'ala wabarakatuh, and hope you're doing well. Today we gonna present a topic about dual piston pump, FST209 principle of food engineering. So this is our group members. First is me, Adib Ashraf, and second is Muhammad Danish, third is Shahid Hafiz, and the last one is Takif Nazmi. So, for the first slide, what is dual piston pump? A dual piston pump is an efficient way to provide a constant and almost pulse-free flow. Second point is one piston pump operating while the other pump gets refilled. It is because those pumps were driven by the same motor through a common eccentric cam. So the third point is this design allows for a more continuous and consistent flow of fluid compared to a single piston pumps. And these pumps are commonly used in various applications, including hydraulic system, pressure washer, and some types of liquid dispensing systems. So for the next slide is component of dual piston pump. So we have four components in dual piston pump, which is pistons, valves, cylinder, and drive mechanism. So for the first one is pistons. It's the primary moving component responsible for creating reciprocating motion within their respective cylinder, alternately creating suction and discharge stroke. And for the next component is valves. Inlet and outlet valves control the flow of fluid. The inlet valve opens during the suction stroke to allow flood into the pump, while the outlet valve opens during the discharge stroke to enable fluid to exit. And the third one is cylinder enclosures, where the pistons move back and forth. The cylinders create the necessary pressure differential for flood, suction, and discharge. And the last one is drive mechanism, which is power the pistons to create reciprocating motion. This can include an electric motor, internal combustion engine, or the other power sources depending on the pump application. So as you can see here, the example of dual piston pump, which is there are dual piston in parallel and dual piston in series. You can see the difference of inlet and outlet. So next we go into operational principle of the dual piston pump. So the first one is sanitary design. Dual piston pump used in the food and beverage industry have to stick to strict sanitary standards. They have smooth and crevice-free surfaces and material suitable for food grade applications. And for the second point is hygienic construction. The pump is constructed with materials that are resistant to corrosion, easy to clean, and non-reactive, with the food or beverage being pumped. Stainless steel is a common material choice for the pump components. And for the third point is CIP, or clean in place capability. Dual piston pump in the food or beverage industry often incorporate CIP systems. This system allows for effective and efficient cleaning of the pump without disassembly. CIP, or clean in place, typically involves the circulation of cleaning solutions through the pump, ensuring the hygiene and preventing the cross-contamination. For the fourth point is the product integrity. The pump is designed to maintain the integrity of the food or beverage being pumped. It should minimize shear force and prevent the introduction of air or contaminants into the product. Next, for the fifth point is gentle handling. The dual piston pump is engineered to handle delicate food or beverage products without damaging or altering their characteristics. This is particularly important for sensitive products like dairy, fruit juice, sauces, and liquid foodstuff. And for the next point is accurate metering. In the food or beverage industry, precise metering and dosing of ingredients or products are often required. Dual piston pump can be equipped with flow control mechanisms such as valves or variable speed drive to ensure accurate volumetric or mass flow rates. And for the next point is customizable features. Dual piston pump used in the food or beverage industry may have additional features tailored to specific applications. This can include temperature control system, product ignition mechanism, or specialized seal to handle high or low temperature fluids. And for the last point is compliance with regulations. The pump should comply with the industry specific regulation and standards such as MOH, Ministry of Health, guidelines, or food safety certifications like HACCP. That's all.
Next, the application of dual piston pump in industry. First is sanitary industry. Dual piston pumps are commonly utilized in the sanitary sector for a variety of applications which require the transfer and handling of fluids in a clean and sanitary way. The following are some specific applications for dual piston pumps in the sanitary industry. Food and beverage processing. Dual piston pumps are widely used for the transfer of liquids such as juices, sauces, dairy products, and liquid additives in the food and beverage industry. They are composed of food-grade materials to ensure product safety and are intended to exceed high cleanliness requirements. Pharmaceutical and biotechnology. Dual piston pumps play a crucial role in pharmaceutical and biotechnology manufacturing processes. They are used for the precise and controlled transfer of liquids, including active pharmaceutical ingredients, APIs, solvents, and sterile fluids. These pumps are designed to meet stringent regulatory requirements and maintain the integrity of the products. Personal care and cosmetics. Dual piston pumps are used for the dispensing of lotions, creams, shampoos, and other beauty and personal care products. They provide accurate dosing and ensure hygiene product dispensing. Second, oil and gas industry. In the oil and gas industry, a dual piston pump can be utilized for crude oil transfer, particularly in applications requiring high pressure, low pulsation, and careful treatment of viscous or sensitive fluids. Dual piston pumps are also capable of dealing with high sand content and low temperatures, both of which are frequent obstacles in crude oil extraction. Some examples of dual piston pumps that are suitable for crude oil transfer are PCM oil transfer pumps. These pumps use the progressing cavity pump (PCP) technology, which allows them to handle up to 99% free gas at pump intake, achieve low NPSH, and reduce ingredient wastage and transfer time. Next, crude oil transfer pump. This pump is built to survive high temperatures of approximately -40°C and is made of particular materials selected to handle the rough oil sand mixture. It also provides the gentle and low pulsation transportation, which helps in the separation of oil, sand, and water.
Okay, next we move to the advantages of dual piston pump. So first, it is infinite solvent reservoir, which allows for long-term unsupervised operation, as well as easy changeover and cleanup capabilities. Second is numerous dual piston pumps are self-priming, which means that no manual priming is required because the pump can remove air from the suction line and begin pumping. This function saves time and effort by making the pump setup and operation simpler. High pressures can be produced by dual piston pumps. The two pistons combined force enables the pumping of fluids at high pressure, which qualifies them for use in high pressure pumping applications, including hydraulic systems and industrial operations. And lastly is the disadvantages of dual piston pump. So the first is the cost of dual piston pumps may be higher than that of the other pump types. Precision engineering and premium materials are needed for the design and construction of dual piston pumps, which may result in increased production costs. This may render them less economical in specific applications, particularly those with minimal pumping needs. Second, comparatively speaking to other pump types, dual piston pumps are often larger and heavier. The pump's total size and weight are increased by the inclusion of two pistons and related parts. This might be a drawback in situations where portability or limited space are crucial. And last but not least, in comparison to other pump designs, the dual piston pump design can be more complicated. Two pistons mean that more parts and systems are needed to coordinate their movements and guarantee correct operation. Due to its intricacy, maintenance and repair may become more difficult and necessitate specialized training. That's all from us.